Welcome, everybody, to the quarterly meeting of the GWEX River Experiment. Today, I am pleased to present to you Guy Schumann, who's going to talk to us about SWOT, and that's really exciting. And Guy is one of the co-leads of our river experiment. If time allows, I'd also love to, after we have a presentation and discussion, I'd love to touch base on the process we've started putting together for community adoption of or community validation or input or whatever we want to call it. We have some suggestions on how we ought to design the experiment. Those are on GitHub on the GWEX RivEx GitHub community. I'll show that later. And but without further ado, I think Guy, the floor is yours. Thank you so much for being here with us today.
Yeah, thank you, Cedric. It's always a pleasure. I have to say I'm not doing these kind of things very often. In the last year or so, I attend conferences and I just enjoy sitting back and doing nothing basically. So this was a bit of an experience for me because I actually yeah, a bit of my background for those of you, I don't see everybody online, but if people are listening and don't really know me and my background is I spend a lot of time actually at JPL, also with Cedric, but soon after I actually changed a bit jobs, but we had the pleasure to work together, and it was actually funny because I came from Bristol University. I'm still kind of loosely affiliated with those guys, and at Bristol I was seen as the Earth observation SAR flat mapping guy. And then they taught me a lot about flat modeling in Bristol. And then I came to JPL and they all said, well, great, we have a flat modeler now. I was like, no, I'm actually the other guy. I'm actually the Earth observation person. Because SWOT needed a lot of hydraulic model simulations for the engineering simulator to mimic what SWOT would actually see in terms of rivers when it's up there. And one of the funniest anecdote, but then I stop talking about me and I go into the presentation. It was actually everybody was saying, "Oh, great, you're going to JPL." And actually, my manager Paul Bates at Bristol, great guy. He said he spent some time at JPL. And he said you should actually make the move. Just go. And I went, and it's very true what he said. JPL is unique in the sense that you have everybody, like different groups, working in the same building or on the same campus. So people literally putting the satellite together, then engineers doing the simulators, and then scientists doing the crazy things, like myself. And there was this one moment where radar engineers would come up to the science people and say, hey, what are the slopes of the world's rivers? And I sat there going, what do you mean? That's why we need SWOT. Now you're asking me to simulate those, but I'm actually waiting for the mission to give us those. So that was a funny discussion, but that's really how all the way these challenges with SWOT, preparing for SWOT, because as a hydrologist, or as many hydrologists or hydraulic modelers, we would wait for SWOT to finally get observables like water level and extent at the same time, where we could actually calibrate, validate our flat models. And there you are, JPL engineers waiting for you as a hydrologist to give them all these variables so they can test the SWOT mission. So it was a bit like chicken and egg, right? Almost. Anyway, it's a pleasure to present this to you. I am supposed to be talking about SWOT observations, but I kept it on advanced river hydrology and flood event assessment. I'm a flood person as well, so I care really about, can SWOT really measure floods and give you flood extent plus water levels at the same time? That would be amazing, because with a good mission cycle, you could then start almost creating these floodplain DMs, right? The full thing. That would be amazing. But so stepping a step back, for those of you who don't know, I hope there's nobody here that doesn't know what SWOT is. If so, I mean, Cedric is here, just ask all your questions to this guy.
Yeah.
I will just try to tell you what the internet knows about SWOT and what I remember. And so SWOT essentially, see, this is already wrong. SWOT is not just a mission between NASA and CNES, you know. Canadians would be unhappy, UK would be a bit unhappy because everybody contributed some money, but indeed it's the largest share of the risk, let's put it like this, is NASA and the French. And I do still remember at JPI going through these phases of, oh well, we got approved. Oh well, what do the French do at the same time? Can they keep the phase? Can they go in parallel with NASA? It's actually scientifically it was beautiful, seeing the two working together in science teams and everything. And the French do have an enormous history with NASA, especially JPL on the ocean side of the altimeter history of missions. So it was a kind of a natural kind of marriage coming together to do a mission. And I don't know, Cedric, if you have more exact numbers, but I think they advertise it still as the $1 billion mission. Um, Now, I can think of a few people that would say that's really too expensive. Does it actually do any value or any economic return or anything? And I would say just looking at a bit more than a couple of years now, I would say absolutely. And I can tell you a little bit about it. I don't know economically, but I can tell you scientifically, it's already well beyond, I think, what it was supposed to be delivering. If you look at publications and science, and again, it's supposed to be a science mission, right? It's not an operational mission, as in the sense it's not caring about right now. Are we doing enough overpasses of a flood event? Are we doing enough for forecasting? No, it's not doing that. It's asking questions of, can we actually map the changes of water storage? Can we actually map something on climate resilience? So can we understand how the hydrology of rivers and lakes and oceans are changing? And then can we actually continuously map this globally? And as a SAR person on flooding, SAR is still really opportunistic when it comes on global coverage. So sometimes SAR is available, sometimes it's not. It's not. Now with Sentinel, it may be more continuous monitoring, but before Sentinel, there was no global continuity in spatial monitoring of SAR. SWOT is the first one in my mind when I heard it's always on. It's never off, switched off. This is unique, but this creates some bottlenecks. We can talk about it later. Like also, how do you get these huge data sets down to people that need to analyze it? So the global coverage is clearly is mind blowing because actually the 100-meter wide rivers, I think, is more like 50 now, or between 50 and 100. The lakes, don't ask me. I think it should be something like 100 by 100 meters is acres. So RivEx synergy of this working group, I think there's a lot here, but above all, it gives these critically observed data that we need for going local to global river modeling that we are supposed to put together here in RivEx. So how does it actually work? Well, I would say ask the French. They developed the instrument. So I'm not very good. I was never a radar engineer, but all I know is that it's a wide swath coverage, but it's very high resolution actually from a public mission standpoint is very high resolution. And it measures the elevations of the water surface and its width at the same time, which is absolutely amazing. Of course, there's large errors as you get into the interface between dry and wet land, but the boundaries have always been troublesome in any satellite capture, also optical. As soon as you hit this change of land cover, it gets into optical. You talk about sub-pixel mixing. In SAR, you talk about, you lose signal coherence. You don't know where the backscatter is coming from, whether it's dry land or water, so it gets mixed. It's very hard to separate, but therefore we have the science team and engineers to work out how to best minimize those errors. The revisit now, it's not great. When you look at this number, you would say it's not great because it has revisit time on average is 21 days, but that's coming over the exact same point again. So if you think about a river moving, actually SWOT is doing much better because it's like you may have an overpass of a river one day, next day it may be upstream or downstream, right? Depends on where you are. And this gives you great dynamics for observing. And especially if you then start coupling it with models, it's fantastic. Um, Spatial accuracy, I don't know if I agree there, but probably yes. I think right now what I see is doing much better in water level in terms of expectations for end users than it is doing in area estimation. I think a lot of people are kind of disappointed when they see the errors in the area estimation, especially the precision of delineating. But SWOT, I've looked through a lot of papers for this talk, and I think SWOT is really it's the elevation that's mostly used. You know, but it's also what we are most interested in when it comes to flooding or rivers is the water levels because they're also gauged. They very they're easier to assimilate than water area into models. They are more linking to threshold process when you say overtopping or not. It's all a question of water level. So when we focus on rivers and ocean, I think it's these decimeter level high precisions that are important rather than the 50-meter pixel on a spatial area precision. So in terms of hydrology measurement, now this was probably the biggest challenge, I would say, unless Cedric disagrees. But when I was at JPL, part of the US science mission, and we traveled to Toulouse and told the French, look, this is what we have. The ocean people were always ahead of the game. They had it well planned, what would change. These eddies, high resolution, they could resolve a lot of the ocean currents, modeling and everything. And scientists from hydrology usually sat there and go like, we don't have a holy grail. I mean, if you say to $1 billion mission people for budgets, if you tell them that we can measure water levels, they would just go, well, you can do that with radar altimeter, can't you? And then as a scientist, you don't tend to say, oh no, we can't. We say, yeah, yeah, sure, absolutely. So we needed to find something that would actually be considered the holy grail and worth putting the money on the table to continue. And this was discharge, right? So if you have continuous measurement spatially and temporally of water level, slope, and width, in theory, you could derive discharge with this simple equation. Now, I really hope nobody from Bristol is on the line because I don't really know how to explain this very well, but I try to remember what I could learn from all these great people. So you have a lot of unknowns there when you have SWOT because you don't know what really the river geometry is like, right? You hardly ever get to the bottom of the river because you have water on top. But if you do have enough measurements from SWOT, rivers should technically change in water flow and width over time enough so that you can start to estimate your A0, right? Your bottom of the river. If you have that and you assume some assumptions with the roughness, you could essentially get to discharge. That's what it is. And that was accepted to be great. And we should get working on that. And then some great minds got together and produced, like, I don't know what the initial number of algorithms was, like over 10 or 20 different algorithms from the SWOT observables to derive discharge with a lot of uncertainty, but it was shown that it's indeed possible to do. And then there was also through assimilation studies. So it turned out this is a great mission. Let's put it in space. And actually, I think when the mission launched, it was actually giving us much better results than we initially thought. I remember still the first post from the French. I don't know where the very tiny canal in width was in France, but there was an image of SWOT, very early release, showing a canal that's probably 10-meter wide. And you could really clearly see this, the bright water surface. And I think just getting a signal back from any satellite you launch in the right orbit is fantastic. But then very early on, making the data look so great and having that great data set that goes beyond the mission requirement, at least at first in width and scale of what we could observe is absolutely fantastic. I think there's still a number of bottlenecks, like for example, how to get these petabytes of data down is still one of the biggest, but that's related to every mission now in space. But then also things like how do we improve on the uncertainties that exist? These noise levels are quite high in SWOT. But I show you now a couple of, so how I structured this is I talk about RivEx and rivers first, and then I go into more flat stuff. But I was truly amazed by how many papers are published. And you see, I only took papers of 2025 and 2026. So if you want to know the details, please read those papers because I didn't want to make this too technical because I didn't know who the audience was. But basically, everything I can imagine was that we could do in river hydrology has been shown with SWOT, to be honest. And I didn't even touch the coastal too much. And also I didn't touch the reservoirs too much, like reservoirs, lakes, because I'm not a lake person. I always feel I need to be careful when I give these talks so that I can at least try to answer some questions. So there's not too much that I did research on lakes, nor on an ocean. I'm not talking about ocean at all. So the ocean community is really, I would even say, publishing more than the hydrology people. And the coastal, these two communities are meeting, but in terms of research, but not very often. So there is some coastal hydrology, but I think there could be more than that. There is a lot on assimilation to update model state output, model output with SWOT observables. And I put here the paper references of those that I read for this talk, and I think are really great. If you want to follow up, please just read them. They are fantastic. They're also not too difficult to follow because SWOT can become quite technical. Um, and so there's also a lot on calibrating this channel roughness and bathymetry parameters that I was talking about, this bathymetry that can be not well observed, but there's a lot of efforts being done, especially also by the Bristol team and the French hydraulic modelers to see if you can, through calibration of the model parameters, use SWOT observables to estimate, to let the model estimate these river bathymetries. And that works quite well. And then here's a nice, very recent paper by the Bristol team on physics-informed AI and SWOT for doing these bathymetry measurements. And that's one area I think where AI can really help because it is literally just on about correlations, patterns, and that's where AI is very strong. And if you constrain it then with physical measurements and meaning, you can get something really powerful out of AI or machine learning. And this is what this paper is showing is really nice. Of course, a lot of these studies have always been done in your usual suspect geographical areas, but that's because you need a lot of verification data when you want to do something with a new mission. So there needs to be gauges, there needs to be other things. So at the moment, there's also not that much publications on ungauged basins for SWOT, a little bit, but I also felt that was there could be a bit more effort on that. And then for validation, using local gauge data and other data to cross-check satellites, like it's always done in remote sensing. There's some things on there, how to validate with water levels measured, and then how to understand the precision and accuracy in SWOT. That's also available very recently, has been done by some people. And then I have a few slides later on where I think SWOT has really mostly advanced the community is these open tools and systems that exist now to serve you. I mean, not near real time because SWOT has this latency. It's not an issue, but SWOT was never built to deliver real time operational data. So, but I think there's still the issue of the latency. People would like to see it more frequently. And there's some discussions later I have from the French initiative on making this the future follow on a constellation mission of little SWOTs. But we can talk about that later. But I think one of the best outcomes of this SWOT mission so far is the community pushing towards very simple tools for people like me to understand the very complex SWOT data and get very cool, easy APIs, easy platforms where you literally click on a river and you have the SWOT height. No questions asked with uncertainty. So that's really great. I'll show you some of that later. So that's some on the rivers, I think. So there's really a big advance on using SWOT to update model state in hydraulic models, calibrating these bathymetry estimations essentially globally, an approach to do that globally, so that we would actually start knowing what's the geometry of a river. And then the validation of SWOT, of course. And then, sorry, I need to speed up a bit because I want to get Cedric some time for the discussion later. But if you then move to flooding, it's a bit more difficult because SWOT is not coming back very frequently. And SWOT has never been defined as a flood or disaster observing mission or helping, like Sentinel, for example. SWOT has not been designed like that. But it's still great. So when there's a flood event and when you have SWOT overpasses, you can really do a lot. And actually where it helps a lot is also when these wetlands start to inundate, because you really see a lot of the dynamics of water levels. It's really great. So there's a lot of these inundation mapping, detecting the spatial extent with SWOT point clouds of water levels. And there are some great papers. This is just some of them, the most recent ones. And then even, and this is actually, I think this is fantastic that they can actually do that with SWOT, is you can measure the wave velocities in the rivers with SWOT. I mean, it's again with models, but in combination that you can actually get to something that tells you about the velocity downstream of these flood waves and rivers. That's amazing. Of course, there's always conditions in the river need to be good for the mission. You know, if you have a river going in the kind of unfavorable direction of a SWOT overpass, you can't do as much as if it goes into the right direction. So I think one of the biggest issues I was saying before, not too much has been done on ungauged basins, and a lot more could be done on these coastal hydrological areas. I think a lot also could be done on looking at more preparedness and response, because again, the mission was not designed to deliver operational characteristics, but I think there's still something you can do for preparedness and response, especially coupled with hydraulic models. So there is some limited papers on looking at informing early warning and forecasting with SWOT information. I think this may be on a narrow river study, and there has also been some on the reservoir breaches with SWOT reservoir heights. So there are indeed papers, but not too many at this point, I think. And then this what is always great in remote sensing, and I think we lost a bit of traction with this principle, is the fusion part. Traditionally, remote sensing has been very great in fusing always different informations from optical, thermal, SAR. And I think if you now speak multi-mission, you can bring in this, like SWOT is an image data, but it's also a non-image data, which means it gives you also a 3D information, which is surface height. But it still gives you something that looks like an image, which is it's an image composing altimeter, I would call it, as a non-technical radar person. So you can fuse optical SAR plus SWOT to get really this 3D volume view of an event. And that is powerful. I think that ought to be demonstrated more for disaster event monitoring. Because I don't think you necessarily need a full overpass of SWOT every time to illustrate that. You can calibrate models that can then mimic SWOT in these 3D water levels. Because when you can do that, you can start to go really into this world of the 3D, the volume appreciation when you have a flood. Or on a reservoir. I think this is a paper on a reservoir where they show this ability to fuse different data sets. So also their preparedness, response, and synergy, I think there could be much more efforts. And I think maybe RivEx could help with this fusion of data approaches with SWOT as well. That's just my personal take. Um, and so, yeah, again, you know all the limitations of flood events. So when you have optical, you have a lot of optical satellites out there, also commercial. But when you have a flood, you need somehow to inform it on other data sets as well to extract something simply because there's always cloud or something else. So if you have a radar like SWOT, it can help a lot. But then at this point, you have the limitation of the overpass. But if you fuse it with other data or you fuse it with a hydraulic model to then use that model to mimic SWOT, I think that would be, during the event, that would be quite nice. Again, here the key characteristics, I talked about this before. Um, but again, this is just to say for the greatness of SWOT, I think it's not the fact that we actually can observe global rivers, but we can observe global rivers at very high resolution right now, and also width plus water levels. We can also see many, many more smaller lakes now. So we're actually aware now of SWOT is the first mission that gives us an appreciation of how many bloody things there are of these like lakes, reservoirs, rivers is massive. And I don't think there's a database yet that captures all these um, freshwater features that exist on Earth. So after SWOT, we probably know a lot more rivers and we know a lot more lakes than we used to before. Um, the revisit cycle, again, is 21 days. It's not great, but I think what is great about it is very consistent. And in hydraulic terms, it crosses a river location, yes, every 21 days on average, but it crosses a river section many, many more times because you can have the following day, you could have it upstream or downstream of your previous location. Of course, that's confusing when you observe it as water level, but when you combine it with a hydraulic model, that model makes sense of this in terms of temporal sequence, and then it's really great. Um, but coming quickly on challenges and processes, I mean, I mentioned it before, this sensor noise is quite a problem. But I think there is also papers that show even after mission, there is a lot of research how to beat that noise level to an acceptable standard for end users. And this is mostly on post-processing done, but there's a lot of that. And there's also AI helps a lot in that in that challenge as well. Latency, there is of course this latency requirement. There should be a rapid release product, and I think there's a French website here that talks about this. Um, this is indeed possible. I think right now, I don't know, Cedric, if that's true what I say, but I think there has always been the discussion on this rapid dirty product that you can just grab and see. And because right now I was talking 21 days, that's the revisit time, but there's a huge latency time when you would need to wait for the release of the data. And that's being constantly improved. New algorithm faster, quicker, and then also deciding on dirty look products. That's being taken care of. I think there's enough research on that. Um, Human influences, it would be great to know them, but maybe it's a bit too early in the SWOT life right now, but also not. Cedric, I think you were involved. I'm going to show you an amazing video at the end of 1 or 2 years of SWOT, what it does to the river flow. It's very amazing. But there is a paper that talks about something I would love to do, or the community to do with SWOT later, is Tamlin's group and George's group did that with Landsat and width. So they actually figured out how much of this is could be engineering influence or naturally flowing. Um, what is the variation in width globally, and then relating it a bit to human activity and influence. I think it'd be great if SWOT could contribute to studies like that, because the granularity of SWOT, especially on flow and water level, is much finer than what you could get from Landsat in terms of hydraulics. I think it'd be great to do this. What's happening downstream of dam, SWOT would be much better to tell you that than any other mission. But then you need to wait for years of data. So we could do that at the end of the mission. Also, I thought, but it's actually been some illustrations being done. I hope the video works later. Then there's another problem, is not much talked about, but I put it here. because it's getting a bottleneck for all satellite data right now. Is this kind of the sheer volume of data. I don't know the numbers again. Maybe somebody closer to the mission has these numbers. But the amount of data produced daily by SWOT, including land and ocean, must be massive. Now, I know early on Landsat, there was always the discussion, does anybody know how much Landsat data is actually being used? So it was always about maybe 10%. But USGS and others always argued there's a lot more used that nobody knows about. So, and then it turned out that with the age of and rise of AI, there is something called Landsat and Sentinel-2 harmonization study. And if you harmonize a cube of data like that, so you make multi-mission consistent, and then you start feeding that to machine learning AI, you can actually get from the 10% usage to about 90% usage. And I think this could be done with SWOT as well. So I do say that the amount of data SWOT produces right now is not really possible for scientists to look at all that data. Let's say that's an impossibility. But there's a possibility for scientists to make sure that data is consistent in error and accuracy, to build, maybe together with SAR data, to build these data cubes over time, and then throw an AI at it. Let it do its job, physics constrained AI. Put it in there and see what happens. Ask your prompt question about how is the flow I don't know, how is the flow on the river Po changing in the last year? Because now with AI, with the real data behind it, I think it'd be a cool answer that you would get. But again, scientists and other people can't do that because we're talking petabytes of data very soon from one single mission. I think the secret now lies in really holding all that data and then throwing a controlled AI at it and physics informed. Anyway, still a lot of challenge in processing, but there are people working on this, very clever people. And yeah, so challenges, noise, latency to wait for the data to come out. How can we measure human impact on rivers with SWOT? And then the data volume needs to be solved. And I think these data cubes with AI, that's maybe one solution to get a lot of this out. This petabyte scale of influx of satellite data is just crazy. Now, maybe 2 minutes on how I think RivEx and SWOT could be very synergetic, because this is a RivEx presentation. So I think we need to start benchmarking these data sets. Like I would love to see, in hydraulic modeling, you have these analytical studies, you have these true benchmark studies where you have a flood event in a certain location, you decide to collect a lot of data in the field, and then so you can test every possible hydraulic model against it. These things need to be done for remote sensing as well. And I know it's being done in soil moisture, for example. You have these super sites right around the world. And also in mission calibration is done a lot. But I think we need to create these benchmark studies. So we need to, like these golden reaches of SWOT, right? Where does SWOT really work very well, fantastically well? And I think there are a few of those reaches known to the community. And then put them there as observed data to validate, calibrate models, forecast models. I think that would be really something cool. That goes a bit beyond the current mission of RivEx, but that may be a follow-on, I think, if we want to focus on SWOT. Knowledge transfer is hugely important. I mean, I lost almost all my knowledge I had on SWOT before when I left JPL. It's very heavy, this kind of technical part. And I think there needs to be a bit on it because otherwise you're lost with these pixel clouds. The great thing is, you don't need to care about pixel cloud. I'll show you later why not. You just log on to one of these community tools and you have a river map, a world map. You click on the river, you click on one height value of SWOT. But then, of course, you can still get to the very complex data. But if you don't want to, these community tools are absolutely great. Human influence, I mean, Again, RivEx could help here with these collaborative projects about these anthropogenic effects on the hydrological cycle. Can we get them from SWOT? And then the open science, always a big thing in this community. But this is one of my last slides. Sorry, this is going on a bit for too long, I think already. But so I'm in Luxembourg, right? Tiny country. SWOT will never measure Luxembourg. Are you crazy? Well, actually, it does. Our big river is not a big river. It's, I don't even know what's the width of the Moselle in its normal state. It's a very heavily engineered river by the Romans, dating back to the Romans. Look, I went into, actually, I don't know which one that is. That looks like the French one. I went into this tool, clicked on, I want my water level on my river, right? Zoomed in, clicked on it. Look, I don't know if you can read this, but it tells you 100 feet, 140 meters above sea level or something, right? Fantastic. So it's, I think it's great that you can actually now, this is a satellite mission. This looks like a hydraulic model on the river, but this is actually a satellite mission. From a point cloud down to putting it so that people understand that when you look at rivers, that this is actually a satellite observable. And it is spatially and hydraulically, it looks very consistent, right? You have, you know where upstream and downstream is, but just looking at the SWOT variability over space. But actually, you could inquire that for every single overpass. It's fantastic. You don't need to be an expert on SWOT. That's why I mean these Beauty Buddies community tools. But of course, they are the standard agency provision tools like the NASA DAC. Knesset Viso is quite nice, actually. And then these specific community tools like SWOT and Tahiti from the TUM team. I think they have SWOT also on there. And then they integrate everything into an API for you. Also other missions like altimeter missions, you can get that fused with other data. It's really great. Anyway, I think this presentation will be shared later. So I just want to spend again a minute or so on to these what could be future. But I've talked about this before, flood warning, maybe more flood forecasting. We need to see how it could be getting more into these rapid response things. Water security, looking at better water management, anthropogenic effects. But here's something interesting. There was a project called SMASH, this small satellites for hydrology, like a constellation of little SWOTs flying around. I thought the mission was dead until I realized it seems, but I had to ask Gemini for that. It seems it's been renamed to Rivalto at the end of last year. Now, I don't know if they finally got the investment to do this or not, but there should be a constellation still the planning of a constellation going on of these public-private partnerships, commercial investment to get into a follow-on for SWOT. Because it indeed, what the first mission showed, it's absolutely amazing what you can do. So people want a continuation of that mission. And it's not going to be agencies putting up again $1 billion, and everybody knows that we are now in a different climate. So I think there's now so much investment money flying around, you should find people that want you to build that as a public-private partnership. Sadly, I hope this is absolutely amazing. I will play this at the end of my presentation. This is, I think, 1 year worth of SWOT data globally and showing you the change of rivers, of river behavior. And it's absolutely amazing. I mean, it's also visually amazing how it was done, but this is what I mean. We could do this at the end of the mission and we could try and filter out the anthropogenic effects or effects of climate change. Recently, these signals have become very strong. I just hit play and hope it plays. It's on YouTube anyway, but it's really nice. Yeah, you can really see these pulses of rivers. And this is not possible to do with any previous mission. And is it important to know? I don't know. For me, yes, I'm biased. I'm hydrologist. I look at floods, absolutely. But maybe for others, meaningless, but I wouldn't say so, not anymore, because we're looking at very much problems on river water supply, on heat, on all these variables. I think it's getting clear to everybody inhabiting this planet that is indeed a big problem. And SWOT is helping to get closer to better understanding why, and then also maybe hopefully find solutions. Indeed, that is I think my last slide. Yeah. Anyway, I'm done. Thanks so much. I think I spent too much time on it, but thank you.
Yeah, Guy, that was so great. Thank you for going through the exercise of trying to summarize, 20 years of mission development and some of the early science. We all really appreciate it. And Delphine Leroux and I have been active in the chat, adding a little bit of information when clarification was needed. A couple of things that I think are worth noting is the latency for the SWAT mission is now 3 days. And you're right that it was initially planned for 45 days, but the data processing, and it's not for dirty products. It's just like the final products are 3 days. So that's
Yes.
good. CNES and Thales developed the spacecraft bus, and the main spacecraft payload, the Cairn instrument was JPL.
Oh, it's the other way. I'm sorry,
Yeah,
guys. I'm
yeah.
sorry. I hope no. Yeah, I'm so
But
sorry.
but listen, there are
Just
like so many different parts of the instrument, the radiometer and the nadir and the Doppler and all that. So like everybody had a pitch in it. And you're right that the United Kingdom Space Agency and the Canadian Space Agency also had a role in there. Delphine put some information on the now
okay.
Valto mission. It's being the concept is being built for 2 satellites, and it should start in 2028. And what else?
Okay.
Thank you so much for showing that video. For the little story, that video was developed by Greg Schirra at the NASA Science Visualization Studio, and
Yeah, I think
what you
so.
showed is
Yes.
my favorite. And it actually happened to be it was a bug at implementation when we forgot to put the background. We forgot to put the earth. We just put the rivers, and that made the earth transparent, and that's what made
Oh, but it looks amazing like this.
I love the video the way
Yeah,
the
yeah. No, you couldn't have done it better because I thought it was done on purpose. This black.
it wasn't, and it turned out to be my favorite.
It's
So
great. Yeah.
maybe we take a moment to take community questions. If you have questions on the SWAT missions or the SWAT mission or clarifications you might have to ask, by all means, go ahead. This is your meeting, so I'll shut up and open the floor to any question from anyone or comments or anything.
I can just quickly add. I thank you very much for completing the chat. It's very true. I've been out of this quite a while, but it's amazing that there's 2 satellites now possible with as a possible follow-on. I mean, this is amazing. Yeah, as I said, there shouldn't be a problem securing money from crazy people that love SWOT. So it's great, fantastic.
Yeah, and,
That
and
is.
I forgot to mention the total data volume is 20 terabytes per day that is
That's
gathered
less than I was assuming. If you
and
now ask me, I
produced.
would have added a zero to that,
And
actually.
it's on a per day basis is still a lot.
Yes.
And since I see you here on camera, Delphine, do you have any clarifications or additional things? Oh, I know you mentioned the various services that we have for data sharing. Anything you want to add here?
Sure. Well, thank you for giving me the floor. I just wrote on the chat about hydroep.next because all the hydrology stuff is not on AFISO. It's actually on hydroep.next, and we've
Yes,
just
that's true.
rebuilt the
Yeah.
entire graphical font, so it's much more user-friendly. So go ahead, have a look at it, and give us some feedback because I think it's been live for something like a week. So you can actually see SWOT data, but not only SWOT data, you can add a lot of different layers. So you can actually look at different types of data, compare them, and look at the watershed that you're actually studying. So it should be a nice tool in your pocket regarding your research. And about Rivalto, yes, so it's been they have started to develop it a year ago, and it should be launched in 2 years now. So only a demonstration of the first 2 satellites, and all the data will be freely available for science. And the
Oh,
company that is actually building the satellites will do some business with this, but for science, we've secured that it's going to be free and totally available to all the scientists. So this is good
Yeah,
news for us, for you.
great news. Yeah, great news.
News, yeah.
It will be available on hydroweb.next as well. So yeah, the idea would be to actually CNES funding the first 2 satellites, and the company is supposed to get the funds somewhere, somehow, for the other 8 satellites to complete the entire constellation.
Okay. That's really nice. Thanks for that update. I really struggle because that's actually where LLM has serious limitations. Because I did ask about the status of Smash, and all it could find from the same website was that I think end of September last year, it was decided to do this renaming, and then it didn't know anything about the securing of the funds. So that's really good to know.
Well, it's more than a renaming because it's not the same technology that's been used
Oh, okay.
on the mini satellite. So we can talk more about that, but that's not the subject. It's another name because it's a different
Yeah. Okay. Great.
instrument.
Great.
But
Thanks for that.
it should serve the same purpose.
Cool.
Any other questions or comments in the crowd before I flash the GWEX RivEx community on GitHub? It sounds like
Actually,
I'm stealing the screen.
I have a small comment about this. SWOT is really complex technologically, and also at the beginning, when I was more active in the science team meetings, one of the biggest questions was how do we make all this data consumable by the community without a problem? Science and users. When how you know when a mission is working is when in a disaster event that was lasting for a long number of months, you get from the UNWFP people a message that they couldn't have a lot of information over that wetland, but they got some product from thermal channels and then SWOT. I kid you not, when I heard that, I was actually asking the person, how did you get to SWOT that? Of course, they had some help from Bristol University, but still saying they were pointed just to one of these community tools. And I think that never happened so clearly in any other mission. This has been, I think it has been pushed from the very beginning, right? These community tools like HydroWrap and yes, they existed for altimeter, but they were always kind of hidden. And when you're searching for something, you knew they existed. But I think SWOT has made this much more visible and much more ideally focused to community. I mean, yeah. I was
Yeah,
very
no,
happy to see
thank you,
that.
Guy. I'm sure the people who've been working really hard on creating a application or action community around the SWAT mission will appreciate your comments. You're right that it's been built into the design, and I agree with you that some of those tools for sharing data openly with application programming interfaces have been really, really, really helpful.
Yeah.
Thanks again for taking the time, the energy, and the bandwidth to talk to us about SWOT. I'm trying. Am I sharing my whole screen? That's not what I want to do. Let me. I'll stop sharing and just share this one. Okay. Can you all see my screen here? A yes or a thumbs up would be helpful.
Yes, I can see it now.
Yes.
Okay. Yeah, so sounds great. I just wanted to bring it to the attention of the community live, or if you're watching later on YouTube, we have a GUX RivEx community on GitHub. It has all of our community guidelines, code of conduct, code of collaboration. We have a link to the official RivEx webpage on gux.org, and but of do we have a link to the project description and also to all the presentation recordings, including the one from today. What I wanted to highlight today is the community discussion. We've already had three presentations on data sets that are proposed for adoption by the community in order to do what we are intending to do, which is looking at the global surface water cycle with observations from space, from the ground, along together with models and advance our understanding of the science and of the management of surface waters. But in order to do that, we need some data sets, and I just want to click on some of those suggestions that we've had for topography, hydrography, and bathymetry. We're proposing a baseline version which heavily leverages the Merit Hydro data set together with Merit Basins. We don't yet have bathymetry for that, but we have a plan. And then a longer term, let's call it a dev version, which would leverage Fathom DEM from the Bristol team. Hydrography has not been produced just yet that I know of for that, and bathymetry is in progress, leveraging SWOT observations. So that's one thing. Anybody is welcome to add comments on there. This is I think probably just a week old, so we don't have a lot of activity yet. But I'd like to encourage everyone to put their perspective on this. We also have a suggestion on space-based river discharge from altimetry and extent, from elevation and extent, and lastly, a proposed in situ data set contributed by the Global Runoff Data Center. So all that is ready for input and conversation. The plan is to reach some kind of consensus as a community. So I would really like to encourage anyone. If you have a question, if you have a suggestion, just consider it a good idea to put it on there. You don't need to be an expert in anything. We welcome everybody's input to make sure that the design that we're putting together is going to be most useful to everybody. So yeah, and the link is github.com gux-rivx, and that'll take you to the main page that leads you to discussions and all that. Any questions or comments on that before we declare victory for today? It sounds like everybody's ready to either get their day started or get their day over, depending on your time zone. Um, then let us declare victory. Thank you, Guy, again. Thank you, Delphine, for the clarification. Thank you, everyone, for joining now live. And if you're watching later on YouTube, thank you. Don't forget to like and subscribe, all that stuff. Okay. Thanks, everyone. Have a great
Yeah,
day.
thank you very much, everyone. Thank you. Bye. Bye.